Welcome to Elixir Wizards, a podcast brought to you by SmartLogic,
a custom web and mobile development shop.
This is Season 14, Enter the Elixirverse.
Join us for conversations about Elixir's interoperability with other languages, libraries, tools, and more.
Hey everyone, I'm Dan Ivovich, Director of Engineering at SmartLogic.
And I'm Charles Suggs, Software Engineer at SmartLogic. And we're your hosts today for Season 14, Episode 7. We're joined by José Valim, the creator of Elixir programming language. José, welcome back to Elixir Wizards. It's nice to have you.
Thanks for having me.
Great to have you back. Top of our mind out of the gate is types and where we are with that. I know we're at 1.19 release candidate, but maybe before we dig into that, for anyone who maybe doesn't know who you are, which seems hard to believe given the topic of the podcast, but what have you been up to recently and what's new with you lately?
Right. Yeah. So, I am José, Brazilian, living in Poland, allegedly created Elixir. And what I've been doing for the last more than a year, for sure, I think most of my time actually goes towards the type system, working on the type system, which is good. It's going to be one of the topics of today. I am involved with a few other things, like a few other projects here and there. Right. In the last years, did a little bit of NX, still do a little bit of live view and live book as well. And recently, one of the projects that we launched as part of Dashbit, something called Tidewave, looking more at the AI side of things. So there's a little bit of work, machine learning, web and stuff, but the main focus is for sure the type system.
What's driving you to devote so much energy into introducing a type system into Elixir? Is this largely driven by people in the larger community? Is this something you always kind of were thinking you might want to introduce into the language?
It's a little bit of everything, to be honest. I would say I am generally a curious person. That's why I end up, doing a little bit of NX, a little bit of Phoenix. Because for me, that's the exciting part about being a programmer is, being able to learn all those different things, the different domains. There's always something new for you to learn. And type systems is something that it's always a topic that I was interested on, right? But I think similar to machine learning, is look, we can find machine learning interesting, but unless we know a good way of bringing machine learning to Elixir that is going to be efficient, that is going to be part of the language, it doesn't make sense to add, right? I'm not going to work on something something that ultimately I would have to tell people, oh, you cannot use it because it's too slow or because it's too clunky, right? So with the type system, I actually did a proof of concept. And I even have this joke in Elixir Conf. I think it was around 2018. Where I actually explored building a type system, reading papers, exploring the literature, by myself for Elixir. And, I worked on it, I think, for about 6 months. So this was before the current announcement, right? And then, I was running into some limitations, and it was really funny because I was implementing something called intersection types, a very particular implementation of intersection types on the Hitler-Mino type system. And then I was running into very bad performance. And then I went to talk to John Hughes, which is a very known professor in the field of functional programming. And then he's like, oh, it's very known that this particular implementation is very slow, right? And then I was like, none of the papers said it. It's the papers, they are on the theoretical part. But when it comes to the implementation, it's kind of known. And then I went to Elixir Conf, and then my joke was, I have 2 news to tell everybody, right? And then the first news was, we started working on a type system for Elixir, and then half of the room started clapping, very excited. And then the second news is that we stopped working on a type system for Elixir, exactly because we couldn't figure out how to do it. And even before the current iteration, even before we announced it to the community, we work on it for almost a year, just kind of trying to see look, before we go and tell the community we are doing this, are we sure that this is something that is going to feel a part of the language? It's not going to be a subset of Elixir, or it's not going to feel you're writing something completely different. So yeah, like the interest has always been there. And this was a matter of like finding the right theory and the right people. So we have been working with the CNRS, with Giuseppe Castagna, which is a very known researcher in this area. We have a PhD student. So the interest was there, but we had to find like the right background and the right people to work on it. And then we put that together with the fact that that's something the community has, like there was a very vocal part of the community and even non-vocal, like say, look, this would be great for, this is something that we're looking for. I remember asking, I think, Electrical Europe, like 2021 or so, like who here would like more like static analysis on the Elixir code base? And it was more than half of the room for sure. So it was clear that that's something the community was interested in, right? But it's also important to say it's not because the community wanted, right? Because I think like when it comes to type system, I hear so many things that are just clearly not true and overblown expectations, be it for Elixir or even other languages, like people saying like, hey, a type system would catch like 90% of my bugs. And I'm like, I think those statistics, like, I feel like the web should, like on Wikipedia, you have like citation needed. I feel like this should be like a feature on all the forums, discussion forums. It should just be able to say, hey, citation needed on this, right? Like, I need a little bit more concrete evidence on this.
Yeah.
But yeah, so it's a balance of all those things. It's the interest, is the community asking, is being able to find the right people, is being able to explain what it is and what we are going to get from it. So all those things, they have to go together.
So then thinking about this like set-theoretic type approach, right, where you're pretty far into it now, I guess like kind of at a high level, how's it going? Are you happy with this approach? Do you think maybe a different theory would have panned out better, or is it going how you would have hoped?
It's going pretty well and way ahead of whatever I tried in 2018, like 10 times ahead, citation needed. But
sure.
But yeah, we are quite ahead to the point that it's part of the language, right? And I think the thing is that we have an existing language and we have the idioms, the code that we wrote. So the big question is, how much of the language can this type system support? Because the type system does not support it. We have two options. We will have to say, oh, this is dynamic code. We don't really understand it, right? Or we say the type system, then just slap dynamic on it and it's always going to be dynamic. Or we have to say, oh, this is a feature that we no longer support. This can no longer be part of the language because it's dynamic and we want to mostly have features that the type system can understand. So we have been working on it, like adding it to Elixir. The theory has been happening before, but the process of adding it to Elixir is going to be 3 releases at this point, which is 18 months. And the amount of things where we say, look, this doesn't work with the type system as well as we wanted, they are very few still, right? And with 1.19, we have basically typed like the huge majority of the language constructs. So that's good. That's a very positive indicator. And for me, that's like, it's the biggest metric that we should tackle right now. Because just to recap, like the type system, it's behind the scenes. We users are not adding type signatures. The whole purpose of the work we're doing right now is that we are typing the language. We are trying to find bugs for you for free. You don't have to change your code. We are just going to go there, type your program, and find potential bugs. So that's the metric. Like, are we going to have like false positives, warnings that should not be there? Are we going to have to remove things from the language? And I think the only notable thing that is kind of saying, oh, this does not really work with the type system, it's the deprecation that we introduced in Elixir 1.19, which is struct update. So if you use the struct update syntax to update a struct, in Elixir 1.19, the first release candidate, which is RC0, it emits a deprecation warning. But that, of course, that caused some discussion in the community. And through that discussions, we're actually able to find a good semantic for that operation in the type system. So we're actually reverting the deprecation. We are converting to something more. But I think it's a really interesting example of like, look, we have this construct. We have to tell what this construct means in a way that makes sense for everybody, that makes sense for existing Elixir developers, dynamic programmers, and static programs. And that was something that was very hard, but it was good. We put the deprecation out there. We got feedback. And they're like, okay, now we have a semantic. So what we are doing is that the next Elixir RC, which I think is going to come next week, is not going to have the deprecation anymore. The deprecation is going to be slightly different. And then when 1.20, before we release the next version, I'm going to have another discussion with the community. Like, well, we upgraded our code bases. We see how this new feature looks like. Do we want to keep the struct update syntax or not? But I think it's a very good example. And we are going, and I believe there is an issue in the Elixir repository where we say features that will have to change, because it's not because they are incompatible with types, it's just because they end up being poor. Like the way we implemented some things do not allow the type system to express the things we wanted clearly. But I think like right now we have two or three entries in the list, right, for all of Elixir. So it's going pretty well. I think that's the digest for the metric that we set for ourselves.
Yeah. I know, like, in our, however long we've been doing Elixir now, long time, the path of kind of upgrading version to version has always been, I think, delightfully not a big deal, right? Like years ago, I think when you were early on the podcast with us, we talked about like, well, is there ever going to be a 2.0? Are we ever going to break anything in the language, right? And it's like, that list of things that could potentially break if you ever did that just has remained extremely short over, 12 years now? That's really fantastic. And this idea, I think something that you said that I really want to maybe peel back a little bit more on is the idea of like, you're not making a type system for the user to interact with, right? The developer isn't typing their language out. We're not adding a lot, or really anything, right? You're inferring it. Yeah, sure. So maybe can we just talk a little bit more about like, okay, so Set-theoretic and the type system you're doing, like what can it do right now? What can't it do? Because you mentioned a little abstractly, like there's some things like the struct update. I don't know. Can you just talk a little bit more about like where are the boundaries of the type system as it stands?
Let me give you like one example. I believe there were 3 or 4 things where the theory as it existed did not support Elixir. So for example, in Elixir, we have maps, and we use those maps for like structs, for like to have structured keys, well-defined keys. And in other programming languages and in type theory, we would call them records. So record is a construct that has a well-defined set of keys. You can add and remove keys, but you usually don't add and remove keys. And those set of keys are like known statically. That's a record. And other programming languages, they have dictionaries, right? Which is, you can say, oh, I have, or they call them hashes, something that is a key value store. You can say that the key is an integer, the value is going to be a string. And so those, in most programming languages, those are 2 distinct data types. But in Elixir, we use maps for both, because maps changes behind the scenes and can be efficient for both. So when we started doing this, there was no theory. There was no way we could implement this. So we actually, and by we, I mean Guillaume and Beppe, they actually had to develop new theory, publish papers, prove that things are correct, right? So that's the kind of work that we have to do. And there is something, for example, and again, like we are being able to support the huge majority of the language, which means that Set-theoretic type is being able to do everything that we needed to do. So we don't have a lot of things that, we can't do that yet, right? Like all those things, the things that we found that we can't do it, we actually did research and published new research so we can do those things. And it's great, right?
Yeah, it's fantastic.
The fact that we are being able to publish research, not only it's great in itself, which means that we're able to get a foundation and extend it. If we were stuck by the foundation like, you can't do it, right? That could potentially be problematic. So that's all we have. The one thing that we are working on right now that we don't have is behaviors. So actually, I should clarify that. So behaviors, like when you, in Elixir, you can define a behavior, right? And you can implement those behaviors. Most of the times you're implementing behaviors. So every time, so a Jill server, for example, is a behavior. It tells the callbacks that you should implement. Most of the times you're implementing behaviors. And with the type system we have today, the theory that we have today allows us to do behaviors as well as we have them today. So you can define the interfaces, what it accepts. So we can do that. We can do the same thing that we do today. But one of the things that I really want the language to have is like, well, if we are rethinking types, I want to have like proper behaviors. And by proper behaviors, I mean, look, I want to say that I'm implementing a Jill server, and this Jill server is going to have this state, and everything is derived for us. All the types, the request, the response, like it figures a lot out for us because the way we do type with the Elixir today on those things, it's quite loose. So it's one of the things that we can't do. There is research going into this right now, and I believe we solve like the biggest problem to make this possible. But we can already do what we have today. It's just that we are being picky and say, no, it should be better. We should bring the next level of features and make those interfaces look more like, type classes in Haskell or more advanced type feature, or even interfaces in Java where you can parameterize the interface or things like that. Mm-hmm. So I'm not giving like very specific examples because when we are finding things that we can't do, like we are trying to solve them because that's our goal for now, right? Is to solve all of those things.
You mentioned dialyzer. How does the introduction of set-theoretic types interact with dialyzer and I guess some of the editor tooling that Elixir developers are used to today? Is it going to make it moot? Will dialyzer kind of go away or?
Yes, that's the hope, right? So the hope is, so I'm treating them as completely different things. And one of the things I did explain in other presentations, but the idea is like we have been writing, somebody's going to say, hey, I just wrote a bunch of type specifications. I want to use my type specifications. And I'm pretty sure, even despite me asking like, don't do it, some people will write like an automatic converter from one to the other, right? But the thing is, the set-theoretic types, they are more precise, they are more powerful than the Elixir ones. And I think an automated translation can be harmful because your type specs, they're not necessarily being checked for this level of precision, right? So it can mean that you're going to write your programs in a very imprecise way that is going to make our life harder later, right? So so let me give an example. Let me try to give a more concrete example, which is, imagine that you have a function that if it receives an integer, like, okay, the unary plus in Elixir, right? The unary plus, if it receives an integer, it returns an integer. And if it receives a float, it returns a float, right? So what we can say is that, well, this is a function that is exactly that. If it receives an integer, it returns an integer. And if it receives a float, it returns a float, right? Like we can say, you can think of two arrows, integer to integer and float to float. That's a very precise definition. So that's what precision means. Like you are giving it a very precise definition on what it does. But you could go today, right, and say, well, the type of this thing is that it receives integer or float and returns integer or float. And that type is also correct because if you give an integer, it is going to return an integer or float. You know it's always integer, but it is integer or float. And then if you give it a float, it's going to return an integer or float. Even for you know that you know it's just going to be float. So those two definitions, we can use them to type the same function. But one is very precise. One tells you exactly that if you give it an integer, the only thing that it can return is it's going to return it. So that's what I mean about precision. So when we wrote Dialyzer today, we were not worried about precision. That's not something that we had to worry about, right? Because even in some cases, Dialyzer, when it's like large type signatures, it actually collapses the types because the goal of Dialyzer is to find a possible error, right? While here we want an actual type system. That example, it's kind of the main point. I want to have precise definitions that capture the full behavior of our code, the full behavior of our functions. And we have not been thinking about this. So we wrote a lot of type specifications that do not adhere to that. And that's why I think we should take this opportunity and start with a clean slate and say, look, we're going to type using these new properties that we want. So in the future, assuming that all this works, you'll be replacing one by the other, right? You're not going to be using that live, you're going to be using Elixir type system. And the goal is that it's going to have better messages, error messages, is going to catch more bugs, and it's going to be faster. So just to give you an idea right now, like we have been working a lot with remote.com. They have a large Elixir code base. And on 1.19, typing their code base, which has more than 12,000 modules, which is a lot, right? It's taking 20 seconds, which is pretty good. Like that's when you compile the whole project. When you change just one file, is going to be, well, you can do 20 seconds divided by, I think it's like, it's going to be very quick, right? And we look at that and they're like, okay, that's too slow. And now we are optimizing it and bringing it down, hopefully bringing it down back to around 10 seconds. But that gives you kind of like where we're going at in terms of performance as well, and finding bugs and all this kind of things.
So right now when a developer is writing Elixir code, the existing type system within Elixir, like it's kind of transparent, I guess, or even opaque. Like it's not something I've noticed personally working in the latest 1.18 release. You know, everything is just working. I'm still writing dilaser type specs and that sort of thing. But as more of this gets introduced to the language, at what point should we as developers start anticipating, planning for, and kind of changing our behaviors a little bit so that our code and our planning works well with the introduction of the type system?
So for now, I still would say you don't have to worry about or change anything. My goal was that for Elixir 1.19, we would be done with the inference things. We would have implemented everything that is inference, so we can focus on actually changing the language and allowing people to have like typed struct or maybe typed signatures. But we did not add. So the funny thing is that full inference is actually implemented, almost fully implemented in the language. We do full inference for everything except for guard. But I like to say that we got to the draw the owl, you know, the name draw the owl that we have on the internet. So like, oh, first you do a circle. I'm not sure if I'm pronouncing the name of the animal correctly. Owl, yeah. Right? Like, so the name is like, yeah, draw the owl. So step 1, draw a circle. And then step 2, draw the rest of the beep owl, right? Like do everything else. And we are kind of pretty much in this stage of type system because we added inference to everything in the language except guards. What happened is that we started having so much type information flowing through the code that it started finding places where it had in our backlog, like, oh, we have to implement this feature. We have to add this precision here. But because this information now is all flowing through, all those things are showing up as false negatives, like warrant or false positives, always get them confused. But warnings that we're not supposed to see, they were showing. And then we're like, okay, now we have to work on all of those things. Like we have to do the rest of the work because otherwise we're going to have imprecise information going through. So we have to constantly refine. And then when we did that, again, more type information going through, which means that we have larger types, which is going to bring some bottlenecks in our implementation, which is natural. So going back, right? So the goal is, we are working on being able to do things so you don't have to touch and do anything. That's still our goal. I was hoping it would be done by 1.19, but now it's most likely going to be done by 1.20, which is going to be end of this year. So there is a chance that by May, June next year, about a year from now, is when we're going to see actual things that you need to change in your code if you want to have better support for those features. So how exactly that is going to look like, we don't know yet. So my goal here would be, well, we'll have these features. We are going to add them to Elixir. And then, because there's always a gap between me changing Elixir and a new version being released, so I'm going to add them to main. I'm going to play with them. and whoever wants to try main out can try main out and give feedback. But there is a chance, it's very likely that, whatever's in my head right now, I'm going to implement it and we are going to try it. And we'll say, well, this is bad. This is not good. So we have to go back. Right. So but basically what I'm saying is like the short answer, don't expect anything before June 2026, June next year. But even that can change, right? So I don't think we should change the way we're writing Elixir code because, again, a lot of what we are doing is to be able to support the code we write today. I don't think we have to worry about that. But if you're like, oh, I finally want to type my things with the new types, I think a year from now, at least, is a reasonable estimate.
I really appreciate the level of thinking that's gone into how to introduce the type system in a backwards compatible way. I think maybe it was a blog post on Dashbit that you wrote that laid out kind of under the hood what's going on with unions and intersections and how you would type a function, and you're drawing on your example of the unary plus operator and how it returns a type based on the input type and how you would write that out and how new types are more of a super type, if I remember this correctly, of what was already there, so that what's already there, existing code, will still function just fine, and you can add the types as you go. I really appreciate that, and I certainly recommend listeners to check out that blog post. It was pretty informative to read.
And that's very important, right? That's something that we had. So it's two things. So at the beginning, my approach into this was, look, we don't have to worry about existing code, because if you want a dynamic program, then you don't write the types, which is basically how we have been writing all along. Oh, somebody's like, oh, I don't want types. I want a dynamic program. Yeah, don't write the types. You already have it. You're good. You're covered, right? So when we started out, I was like, I don't care about the dynamic things. But after the work started, it was when we realized that, hey, we can actually, so like this idea of having full inference for Elixir code base, I think a year ago, we did not have this idea. It was like a very recent realization that's like, wait, what? We can actually type. We can actually have full inference for everything. So in a way, like the schedule that I had for this actually got postponed because we added new features. So there's a scope creep happening there. Never happened before, right?
Yeah. First scope creep ever in the world of software development. Yeah.
Yes. So, but it's because we realized we can do that. And then we are even bringing more features. But it was very important for us to be like, look, we don't want to have and that's how a lot of other languages, when they added the types, that's how it behaved. Like they would run the type checker, and then the type checker would come up with a bunch of violations that they're not actual bugs. It's just the type checker being like, yeah, you can't write this. So it goes back to what I was saying. Like that's something I wanted to avoid since the beginning, right? Like the existing code, we should only say it is a bug if we are 100% sure it's a bug. It's not because I don't quite understand this, and then the type checker is like kind of giving up. Yeah.
What is the world of kind of downstream impacts of what you're doing been, right? Like we talked about for the developer, the idea here is no change, right? You just get more useful warnings from the compiler about your types. But what about Livebook, CI pipelines, language servers? Have you started to see any kind of impact on that work at all?
I would say it's still too early for us to see that. I mean, we are definitely seeing bugs being caught. Right. So there are people when they upgrade, the type system found that code. Like we found that code on Phoenix, on LiveView, on Livebook itself. So even some bugs we find in those projects as well. So I think it was Livebook. There was a place where we were doing a rescue and then e.message. So we were kind of assuming that all exceptions have a message field, and other types is you can't assume that. So we're definitely finding bugs. But the thing is, when you upgrade your Elixir version in your existing code base, it is hopefully a code base with tests, right? Because we need test types. They're not going... I talked a lot about this. We can talk more. It's a separate topic, but we can talk about it later. types do not replace the need for tests, right? So what happens is that when you upgrade your Elixir version and we do find a bug, it's because it is a bug that your tests are not catching, right? So that's why I say like it's limited what we are getting and seeing because you already have the tests that are catching all those things, right? So the test already caught many of the bugs that the type system would have caught. So I think like the limits of our work, it is still the impact. It's limited given the nature of where we are in the implementation and where we are as a community. But the goal is for it to increase. And there are things that we don't do yet, which is, for example, it's implemented, but it's not going to be 1.19. It goes back to the full inference thing. Is that if you call ecto passing a bad argument, we are not considering the types that we inferred from ecto. We consider just a little bit. We don't consider it fully. So like the amount of information going through, it's still limited. But yeah, so in other words, I don't think we are seeing that now. I think we are you can get a warning OCI, for sure that can happen. But we are mostly fixing them when we find them in our machines. And it's still too early for IDE integration, for example. So one of the questions people have like, oh, can you infer the type? If Elixir is inferring the types for my functions, can you show me? Can you go and add the type and show it to me? And I am like very skeptical about doing that for now because I think those types, they can be huge, right? Like, because imagine like you have a function with many clauses that calls a function with other many clauses. And if you're just getting those signatures and giving them to the user, they can look really bad. While what you should do is that, well, so imagine one of the examples I gave recently is imagine that you're doing payment processing. When you're doing payment processing, the thing can go into a couple different statuses, right? It can be, it can be overdue, it can be on trial, it can be okay, right? The user can have canceled, right? And all those things today, they are patterns in our code base, in our function clauses, right? So if we just say, hey, infer this for me is going to give you like a huge union with all those things, right? And the correct would be, well, I want to define a type called the status that define all the possible types. So you break those things into proper definitions, and then you start using that in your signatures. So basically, I think short is we don't have anything right now, but I think I want to be very careful also with that part, right? I don't want to say, hey, here's the type that we inferred, right? I want to make sure that everything that we are doing is conscious, nothing is like automatic. And I know that means work. And sometimes people are like, don't make me think, don't make me work. But, I think it's something that is important enough that it does deserve some thinking. It does deserve some working.
So right now, all of the output from the type system work is compiler warnings, effectively, where we're at right now.
Yes.
Okay.
Exactly.
So if you're doing the right thing, which is in CI, you're doing -- warnings as errors, then your build will fail with your types.
Yep.
Awesome.
That's all you did.
Okay.
Perfect.
Man, developer experience, man. That's just it just happens, right? Your code is just more checked.
Yeah, I could use more supervision.
Awesome. So things are going well. Things are going how you'd hoped. Maybe you wish you were a little further along, but yeah, I mean, I can tell you from the outside, it's been like just easy, right? Like it's like it's not there, but we get the value of it without having to really think about it, which is probably the best case scenario, right?
For now, yes.
For now, yes. Yeah.
Right? Yeah. But that's the thing. Like, if you're happy with the status quo, right, you can still stay with the status quo in the future, right? You can just say, I don't care about types. I am happy with the amount of guarantee that Elixir inference gives me by default.
Sure.
And if you're happy with that, then you're good. You just continue doing whatever doing. As I said, just have -- warnings as error, and you're good. But if you want, look, I want proper type, then you have a full banquet to enjoy.
Right. In about a year, you'll have some syntax you can add to do something. Yeah.
Potentially, yes.
Fantastic.
I feel like I've seen the LSP tell me about type issues that I hadn't noticed before, but I'm assuming it's just passing through something it's finding through recompiling the code as opposed to anything that's built into the LSP specifically.
Yeah, so the compiler emits diagnostic about what went wrong during compilation. So from the LSP point of view, a undefined variable warning is the same type of diagnostics as a type violation. So the LSP is just getting all of those.
Mm-hmm.
So whenever you improve Elixir, you get it as a warning on CI, and it also shows up in your LSP as a warning as well.
Has this impacted any of the work on the Elixir LSP project? Are they interacting, or is that entirely separate tracks of work?
So I would say it's still entirely separate tracks of work. We have a shared communication channel, and one of the good things about establishing this channel is that we can give and receive feedback early on. So of course we are being very mindful of what is happening there. But I think given both are still highly in development, they are separate tracks.
How is the LSP project going? Is there anything you're able to share at this point, or is that still people are heads down making it happen?
Yeah, so I am not involved on it directly, to be honest. So I know they are working on it. I know there are companies sponsoring the work like Fly and Tall Spades. So those are two companies that are sponsoring people working on the project, and the project continues to develop. But I really don't know like the exact details of where they are, So that's an episode to have with them.
Yes.
Yeah.
Absolutely is. Is there anything else ongoing in the Elixir universe that are part of day-to-day Elixir developers' work that ties into this or that you'd like to bring to the table today?
In particular with types, I'm not sure if there is anything worth calling out. I mean, I think there are things. So one of the things that I mentioned and in the topic of interop that I mentioned in the keynote was having types can also potentially mean having interop at the types level. For example, what if I can get an Elixir type, a struct type, and convert it to TypeScript and use that to have better integration between front end and back end. So that's something that we actually built some proofs of concept. Anyway, one of those options. Or maybe proofs of concepts. Anyway, but yeah, so we did build some exploring those ideas. So I think that can be interesting, but it's too early. Of course, there are like many things happening in the ecosystem in terms of interop and AI, but I think like types related, it's still mostly still on core.
Yeah. I mean, I think that's a testament to the approach that you guys took here, right? Is how focused it can be, how much you'll be able to give the developer for really no effort from our part, lots of effort from your part.
Yeah.
But I mean, this has been fantastic. It's really great to hear kind of where things are with all of this. And, the experience, I think, at least for me, has been so like it's not a big deal that I think it's easy to think that it wasn't really, that you haven't gotten much. But I think the reality is we've gotten a ton. And the fact that we don't know it is really just a benefit of how great this language is and how great the work that's going on behind the scenes is.
Our goal for now is to be like conference Wi-Fi, if it works, everybody's happy, nobody complain, right? And if something is wrong, somebody's going to complain loudly so we can fix it.
Sure.
But yeah, we hope to stay mostly still like, everything is going. And so there is like a big companies, there's a word for this. They do, I think it's like, let me tell what it is. When they want to add a new feature, they launch the feature like kind of disabled to see like the load on the server. So I think like Facebook did that, for example, when they launched the Messenger, the first thing they did is that they loaded the Messenger on everybody's page. They loaded the whole thing, right? Had it send like the initial messages, but without ever showing to the user. So they could exercise the performance, the impact this would have on their servers. There is
Right.
this thing has a particular name. There is this technique, right? And that's also the other thing, because we are talking a lot about, well, getting the warnings, but it's also very important. The warnings is, we go back, the performance should also be really good. That's the other benefit of this approach, is that the type system gets more complex. Every release, we add more features. It's doing more work, and it should be fast, right? And when it's not fast, like it's getting stuck in some cases, and then people do the report. That's when the conference Wi-Fi fails. But people do the reports and then we fix them. But that's the other very important thing for this, right? Because it will happen, but it would be really hard. Like if people like, oh, I added this type signature and now like my program takes, 30 minutes to compile, which will happen because we are going to have like all type systems. They have those things. They have those really corner cases where a lot of type systems, the algorithms, their theoretical complexity can be like very high. It's just that we don't hit those particular cases in practice. So that can be for everything. So that was the other thing. And it gives us confidence, the fact that we keep on adding features and the compilation times are good. And when they got bigger than you were expecting, we can do the work and bring them back down again. And yeah, that's all very exciting.
In terms of maybe like asks for developers who are trying out 118, 119, the release candidates, all of that, sounds like let you know if things take a long time, if it takes a lot longer to build than it used to, and developers should not be ignoring their warnings.
Yes.
Beyond that, are there any asks for the audience or any plugs you'd like to make?
Yes. So very good. So I'm going to recap yours. So before you upgrade Elixir, do a mix compile --force, and there is a flag called profile time. So mix compile --force --profile spacetime that is going to compile your project, fully compile only your project, measuring the time it takes for compiling and the time it takes in particular for the type system, which we call group path. That's the group path. So then you upgrade Elixir, you compile everything, you run your tests, see if you're happy. If you're happy, then you run it again. Mix compile --force profile time. And you should see, large projects should see like a big difference in compilation times in 1.19 because we did some work on this area. So I was talking about remote, their code base is compiling 3 times faster, which is just amazing. So that's one thing you can do, right? So you do that. And don't do that on the release candidate 0 that is out right now. So we are going to announce release candidate 1, and then you can do that because we already know, we already got the reports of bad Wi-Fi. We already know that it's failing in some cases. We fixed those. We are working on the next release. And then when RC1 is out, please try it again. Let us know the times. Let us know if things are looking good as we expect them to look. Yeah, so reporting the times, try out the RCs. And yes, please don't ignore the messages. Go for the messages. And if something is making you scratch your head, don't say like, I'm not too smart to understand this, or this is confusing. If it can either be, I would say that most likely it's a bug in both cases. So if you get a report, you don't understand what it is. It's most likely a bug in Elixir. We're not supposed to be getting that report. Or it's most likely a bug in Elixir. We could be doing a better job in that particular report so it's less confusing for you. So if you're upgrading, you see a warning, you're like, oh, I can't solve this. I don't know what it wants me to do. Let us know because it should be clear. We should be saying like, hey, you were expected to do this, or, this is the change you need to do, or there is a bug in your code, and here's how you can spot it easier. So yeah.
Awesome. Well, thank you so much for your time. And this was just a great update on where we are with types in Elixir. And yeah, hope to have you back again soon.
Thanks for having me. See you next time.
Yeah, thanks for joining us, Jose.
Elixir Wizards is a production of Smart Logic.
You can find us online at smartlogic.io. Don't forget to like, subscribe, and leave a review.
This episode was produced and edited by Paloma Pachenik for Smart Logic. Thanks for joining us, and we'll see you next week for another episode as we enter the Elixirverse.
Hey, this is Yair Flicker, president of SmartLogic, the company that brings you this podcast. SmartLogic is a consulting company that helps our clients accelerate the pace of their product development. We build custom software applications for our clients, typically using Phoenix and Elixir, Rails, React, and Flutter for mobile app development. We're always happy to get acquainted, even if there isn't an immediate need or opportunity. And of course, referrals are always greatly appreciated. Please email contact@smartlogic.io to chat. Thanks, and have a great day.